Hi and welcome back to a new video. Last time we tested this ASUS Equalizer cable, and the short summary was that the current distribution using this cable was actually a bit worse than using other common cables I was using so far. ASUS still claims that this is fine because ASUS says that this cable is rated for a higher current and thus this is okay. ASUS says it can carry up to 17 amps per cable, which is mainly caused apparently by having improved contacts in the front of the connector. Today we want to investigate exactly those connectors and also see what they actually did with this bridge. Thermal Grizzly Duronaut is our new high-end thermal paste and the successor of Cryonaut. It's even better performing, it is much easier to apply, it is cheaper, and it's much more durable. That's where the name comes from. Especially if you're now maybe considering to buy a new PC, then I would highly recommend that you're looking into this thermal paste. So let's continue with this video. First, I'm interested how they made this connection, like the bridge that is connecting all the 12-volt wires and also all the ground wires with each other. I guess ASUS did this because they were under the impression that having a bridge very close towards the connector in front would even out the current more than on a normal cable. But we saw that this was not the case. We will first start testing again the cable number 3, the one that we used already in the last video, the one that performed the worst. And you can see it's again triggering the wire view. And we can see the highest pin is pin number 5 with 10 amps and the lowest is pin number 1 with about 6 amps. This is interesting in the way that the minimum and maximum difference of about 4 amps is the same than when I tested this last time, but it's a different pin. Previously it was pin 1 that was the highest and now pin 1 was the lowest, so that's not really consistent. But you also have to keep in mind I'm like plugging and unplugging every single time, right? I'm plugging again on the PSU side, plugging again on the GPU side, so it's like mechanically every time a little bit different. But that's just an interesting thing to see. But now I want to take this apart and see what's inside here. You can take out the sense pins, that's no problem, but the rest of the pins is like, I don't know, almost like, it looks like glued in almost. Well, that was just a cover. I thought we can access something underneath, but That is not easy to remove, but just cut this open and you can see a look at the 12-volt rails and you can see some sort of a bridge and also 3 screws. I made some really good progress. You can see it's essentially 2 bridges. I took them apart. They are separated by a thin piece of black plastic in between. Otherwise, you would have a short. If they would touch each other, then you would have a short between 12-volt and ground. But you can see 2 big bridges, 2 metal pieces just connecting, so 12-volt side and then also the ground side. And I guess with removing these screws, we should be able to remove the bridge. Top part is just one small metal piece, which is also connected to the voltage sense that would then go to the Thor PSU. And underneath we have this metal piece and the individual wires with the removed insulation. And that's bridge removed. I separated all the cables, removed all the glue, and now we can insulate them so they're not touching each other, and then we should be able to test the cable again without the bridge. Might not look super professional, but should still work. I first insulated all the ground wires and they are also still bridged together because it doesn't matter. And then I insulated all the individual, is it insulated or isolated? Isolated probably. Isolated all the individual 12-volt wires. Attached everything back to the same PSU, still same setup, nothing else was touched, and we're now checking again current distribution. Well, so that is not the prettiest current distribution, but it definitely improved. The lowest pin is now about 7.5, highest is just below 9, so it improved from a delta of about 4 amps to a delta of about 1.5 amps. Now, if you're wondering why it actually improved after removing the bridge, that is something I explained in the last video, why it's expected that the current distribution is worse using this type of bridge right in front. Another thing that the bridge is causing is that this entire thing in front is pretty stiff. It also means that the pins themselves can't easily align to the connector. While you might think this is something good, so you can't accidentally touch it, I'm not so sure. There's also the fact that this is now pretty long, and if you plug this into your card, you're left with something quite long before you can bend it, and that might also cause compatibility issues, for example, with your case. One thing we didn't talk about yet is the material of the connector or the pins themselves. If you look into the equalizer, you will see they are gold plated. Whereas if you look, for example, in my Seasonic cable or like a random Amazon cable, they're usually tin plated. So it's a copper alloy that is tin plated and then looks silverish. The only other cable I have is this Asia horse. You can also look inside and you can also see gold plating in here. Unfortunately, it's difficult to generalize if gold plating is the better option. So the base is always some sort of copper alloy that is used in the connectors themselves. And usually you wouldn't have naked copper because it oxidizes real quick. That's why most of the connectors are tin plated. That also helps in assembly. For example, if you solder to a wire or if you solder a connector to a board, a tin plated contact also helps with soldering to the component. So that is definitely an advantage using tin plating over just leaving it bare copper, which is something you just wouldn't do because it would quickly oxidize. And that is also the reason why you're often switching to gold plating for the connectors, because it's also much better versus oxidation than tin, and it also is electrically more conductive than tin. Now you might assume that gold is always the go-to choice, but the problem is the material mix, because on the GPU side you would still have the copper alloy that is tin plated. So you have the gold that is on the connector, and this is usually not pure gold, it's some sort of alloy that is super hard, usually also harder than the tin surface. So you have the gold and then you have the tin layer in the GPU, and if they're mating, then it also means that typically the gold surface is scratching across the tin surface. And this can have some small tin particles becoming off the surface, and those quickly oxidize. If this happens a couple of times, due to vibration, then it can actually be worse in terms of contact resistance than just going with a traditional tin-to-tin connection. It is a kind of rule of thumb that you always have to use the same mating contact surface material. So you either go with gold to gold or tin to tin, but it should generally be avoided to mix these. Now, if you're checking the ASUS Thor PSU, you will realize that it's also gold plated on the PSU side. So it would actually make sense that they have the equalizer cable with gold plating on the PSU side. It would make sense that they have the gold plating on the PSU side and have tin plating on the GPU side, because even an Astral card is not gold plated inside the connector. But yeah, since this is also somewhat of a universal cable, they would also sell this to any other customer who is not using a Thor PSU, right? And then having gold plating would not make any sense. So yeah, having gold plating as an argument, probably not. Earlier in the video, I was also talking about that the contacts themselves in front of the connector were changed. ASUS is talking about that they changed the spring contacts inside the connector and that they increased in width, which allows a higher current. ASUS provided this table to me with changes, and they are comparing this with a traditional 3-dimple design, which is tin-plated. You can see a picture of that on the bottom. Now ASUS is talking about a width increased 4-spring contact design with 23% more width. And this is supposedly reducing the contact resistance and also the thermals or the temperature. The 4-spring design is not fully new though. I remember an article from about 3 years ago from Igor where he was going into details of the 3-dimple design versus the 4-spring design. Also, both of them are still used today. I ended up with an entire zoo of cables on my desk. I ordered like 6 or 7 12-volt high power cables, and I guess the most interesting comparison will be from the Asia horse, which is also gold plated, to the ASUS cable that is also gold plated. Well, now I just have to find out how I can remove the cables and the contacts without damaging them. Finally, time to use the Dremel again. One detail that is already interesting is that only the tip is gold plated and the cable contact point should be tin plated then. And I want to extract the same thing from the Asia horse cable. I also noticed on this one that there is a PCB inside where the cables go to, and then that's where the connector is sitting in. That wasn't easy, but at least I have one individual pin now. And for a third comparison, we're using this new thermal protection Corsair cable. Never used this one before. Still have some backups. There will be a video about this one at some point, but I will just take this apart first. Interesting, so Corsair seems to be using this 3-dimple design. Okay, we'll also take a fourth one, fast gear, just ordered from Amazon. And it seems like this one could also have the 4-spring design. I prepared the samples for the scanning electron microscope. So all on the left we have the ASUS cable, then on the bottom is the Asia horse, top right is the Corsair 3-dimple design, and then all on the right we have the cheaper Amazon connector. loaded all 4 samples in the SEM, and then we were checking them out. Inside the SEM, vacuum is pumped, chamber is ready to go. We have the 4 samples, so the ASUS, HR Corsair, and the Amazon one. And now I'm further preparing that we can investigate it further. And here we have the ASUS 4-spring design. That is the one I left in one piece and didn't take further apart. First thing I checked is with EDX analysis, the material on the surface, and that is the composition you can see right here. So we have about 54% of gold, we have 30% nickel, we have some oxygen and also some copper. That is kind of expected. Oxygen could be just some stuff that is sitting on the surface. It doesn't mean that the gold or anything is oxidized. That could just be impurities from the sample preparation. That is quite normal. And if we are going through the materials right here, so you can see the presence of gold and also the presence of nickel. They are sitting basically on top of each other, and that is also pretty much expected that you first nickel plate a contact before you can gold plate it. What we were just looking at is the one on the right that is still fully fine, like in one piece, not modified. And the piece in the center is basically a folded up connector, which should allow us to investigate or even see the contact patch of the spring design. So definitely on the left, this could be one of the contact patches where it has direct contact, and also maybe on this spring, probably that area. So that is quite interesting. I'm doing an EDX analysis again. And just going through the different colors, you can see that the teal color, that is gold, and that is just overlaid right here. Can enable, disable the teal color, so that is the gold. And what you can see, what is yellow right here, that is tin. So go here, so there is this, so you have a couple of tin hotspots. Those are probably exactly on where the connector is mating. So probably here, on the left, and also on the bottom where the gold would touch the tin, you can definitely see tin residues on the mating surfaces. And we will now zoom into this contact patch where we found the tin. Now this is zoomed in onto this contact patch, and we can now again check the material. So if I add in gold, that is everything that you can see in teal color. I can also add nickel, so it's nickel overlaid with gold, just removing the nickel for now. And yellow is tin. So especially here on the left, where it's almost like some stuff that got stuck on the surface with like some shear motion. You can see all those particles are just tin residues sitting on top of the gold. So gold, teal, and then some of the tin residues on top. What I also find interesting is how little of the surface area is actually making contact. So I switched to a different detector, and this is giving us a material contrast. What you can see dark is tin, so on the left right here, and also this and that. And we're essentially looking at 2 sides of the 4 springs, but it's just this patch and those 2, so it's not too much surface area that's actually making contact with the connector itself. And that would be the Asia horse connector, and even though this also appears to be a 4-spring design, it definitely is physically different. That would be the Corsair contacts with the known 3 dimple design. And this would be the cheaper one I bought off Amazon, but just from the shape definitely reminds me of the Asia Horse connector, just that it's not gold plated. It was super interesting for me to see that it also confirmed the theory of the material mix of tin and gold and the interactions that are being caused. Directly on the contact patch we could find tin residues that are being stuck to the gold surface. And zooming in further, we can see that this is kind of looking ductile, almost like it was smeared across the surface. However, I was also able to confirm that the contact pins inside the connector are actually different towards the rest. The material thickness seemed to be quite uniform, with about 200 micrometers, which equals 0.2 millimeters. And looking at the ASUS spring, then you can see it's slightly longer, and on the bottom, the width is also slightly larger. With the Asia Horse cable, I'm actually not quite sure if this is a real 4-spring design or if this is maybe like a 2-spring design. At least the parts on left and right are not really bent, and I'm not quite sure if these would have contact if the pin is inserted. With the fast gear cable that I bought off Amazon, I can definitely tell that this is a 4-spring design. Compared to ASUS, I can see, however, that the springs are slightly more narrow. I'm not sure how relevant this really is though, because if we're checking this, we can see that the contact area itself is much smaller than you might think. With only 0.2 to 0.4 millimeters, the diameter of the actual contact patch is much smaller than the spring itself. Now that we have all the information, we can finally draw a proper conclusion about the equalizer cable. I guess the name comes from the bridge, which was intended to make the current distribution more equal. Turns out, we already explained this in the previous video, that in theory it might make things worse. And we even proved it in today's video that removing the bridge was actually helping. So yeah, I'm not quite sure about this feature. ASUS definitely did changes towards the springs of the connector itself. They widened the contact, which in theory allows for a bigger contact patch. But we also saw that in reality, the contact area might be much smaller than you might assume. And that's why I'm not sure how much or if this even helps anything. With the gold plating, I'm also still not quite sure. We had the theory that you have to avoid those material mixes, and we could even prove that some of the tin was sticking towards the gold layer. What still confuses me the most is ASUS rating of 17 amps per wire. It doesn't make sense. If you think about it, the wire itself is not much different from, let's say, a Seasonic cable or a Corsair cable, so there's not really any change. There are changes towards the springs in the connector, but they are very small changes. And then going from 9.2 amps as a spec to 17 amps, that's almost double. With this small amount of tweaks, I'm not sure. I'm not sure how they came up with that number, but honestly, it doesn't sound plausible to me. It's a way too big of a jump for the small amount of changes they applied. And some of the changes, like the gold plating and the bridge itself, might sometimes even make things worse. So overall, if I'm just looking at everything that we discovered, I would probably not recommend this, especially at the price of 50 euros. I mean, you can buy any probably other 12-volt high power cable at half the price, and it's just the same gamble, so I don't see it. All right, hope you enjoyed this video. See you next time. Bye bye.